Guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the Byjus Exam Prep. And yes guys, this is Rakesh Sir once again live into the session to continue our concepts on the engineering mathematics. As you know, we started up with the calculus since the few days, and last class we discussed the mean value theorems, the important mean value theorems. As I told you, the questions are also expected in the competitive exam, whether it is GATE or ESC or other exams involving this subject. And yes guys, so let's continue forward and discuss the applications of mean value theorem. Oh, sorry. Yeah. Let's go and discuss the applications of the mean value theorem. The applications of the mean value theorem going forward. Yes guys, so let's get started. Let's get started with the session. Now, as I told you, mean value theorems are pretty much related and pretty much based on the concept of continuity and differentiability. Very good evening all, very good evening. Keep joining the session. Just keep joining the session. Right, yeah, so this is a brief intro about me in case somebody new to my session. This is your mentor and educator Rakesh. This is your mentor and educator. Just a second, what is the issue that is coming? Yeah. I have secured All India rank 9th in the GATE examination, completed my Masters from the Indian Institute of Science, Bangalore. It's been more than 11 years, having trained more than 50,000 students. I commonly deal with control systems, signal and system, EMFT, and digital electronics in the tech domain, and I also deal with the engineering mathematics and aptitudes in the general non-tech domain. Right. Yes guys, the Hall of Fame BYJU'S Exam Prep student really outshined in the GATE 2022 examination, having secured All India rank 1, All India rank 2, All India rank 3, multiple under 50, multiple ranks, achievers under 100. I hope that you are also one of them in the upcoming years, the GATE 23 or GATE 24 examination. Right, and in case if you find that the sessions you are attending regularly, like maths is going on Monday, Wednesday, Friday, other than the maths, signal and systems I am taking for ECEE and IN students. For mechanical civil, SOM is going on, right? That's what is the complete idea. For computer science, programming and data structure is going on. The complete schedule is available. You can take a screenshot of that also. So multiple sessions are going on. Other than this, guys, if you have appeared for the GATE, if you are a GATE aspirant, let me tell you guys that, foreign universities through GATE. Let me tell you, foreign universities through GATE. It's a big charm, right? But many students are not aware that foreign universities, okay, they, some of the foreign universities, especially of Germany or Singapore, they recruit through GATE. They take their admissions through GATE. But how? What is the cutoff? How to apply into them? That session is going to be taken tomorrow by Anshul sir. Then we'll have some more strategy session of preparation. We'll talk about artificial intelligence and data science. So lots of things are coming up into the channel. So if you're liking the content, if you want more such content, do not forget to subscribe the channel so that we also see how enthusiastic and interested you are in these types of sessions, and so that you can also get the chance not to miss any of these sessions. Acha ji. Right, now the application of mean value theorems, we have understood guys. In case you couldn't watch, you can go and once again watch the class. On the mean value theorem, where we have discussed everything about the mean value theorem. Right, we'll discuss everything about the mean value theorem, and definitely now we'll talk about the questions which are related with the mean value theorem. Now you will see this question where you are absolutely not going to see anything that says mean value theorem, but yeah, where all mean value theorem can be applied, that's what we are here to learn. So please look into this question and let's see how to answer this question. Just let us see how to answer this question. Good evening all. Once again, keep joining the session. All update your friends, and do like the session. Yes guys, please solve this question and allow me a minute as well. Just very soon I need to update on something. Yes guys, anybody getting the answer for this one? Sure, Shravan, we'll try to update that also. Yes guys, anybody getting the answer for this question? The mean value theorems. Just a second. If a plus b plus c equal to 0, then one of the roots of the equation 3ax square plus 2bx plus c equal to 0 lies in what interval? Lies in what interval. Okay, the video quality is fine, or is it little blurred? Let me check that. Let me just again check the video quality once, guys. Yeah. Yes. It's fine now. Shanu, how we can study full course from you? Shanu, yeah, if you want to register for the full course, you can just go to the BYJU'S Exam Prep app and, get the information from there. It's easy and sufficient information. So yes, guys, as I told you, there is nothing that you are going to see with respect to what? There's nothing that you're going to see with respect to mean value theorem mentioned, but one of the application of mean value theorem, especially Rolle's theorem, that is going to come up here is key how to solve an equation. One of the root of the equation lies in what interval? So one of the roots of the equation, what you are going to do, whatever may be that equation, let that equation be, okay, let that equation be named as f dash x. Let f dash x is equal to 3ax square plus 2bx plus c. Whatever that expression is given, guys, take that as f dash x. Just take it as the f dash x. Okay, ji? Acha. So if this is the value of f dash x, then what will be the value of fx? The value of fx will be equal to the integral of the f dash x. Right? And when you integrate this, the integral of x square is x cube by 3. So 3 cancel karte hue, this is ax cube, then x square by 2. So 2 and 2 cancel. The integral is bx square. Integral of c constant will be cx. Plus we add the constant of integration. That is suppose the d. So what is the value of fx now? What is the value of the fx? Ax cube plus bx square plus cx plus d. Okay. Now, in what interval this equation is going to have a root? Here is what you're going to see is an application of Rolle's theorem. Now please see how Rolle's theorem comes into picture. This fx, this particular fx is what? This particular fx is a polynomial function. All right, everybody. This particular function is a polynomial function, no doubt. Now, since this is a polynomial function, so what we know about the polynomials, we have already learned what we know about the polynomials, that they are always continuous and differentiable. Right? Always continuous and differentiable. No, Nikhil, that shouldn't be the case. Okay, if it is the case, I'll update our team. Okay, so this polynomial function is always continuous and differentiable. Acha ji. So I have few remarks about the function fx. Right, I have few remarks about the function fx. The function fx is ax cube plus bx square plus cx plus d. Now it is continuous, suppose in some closed interval ab, because it is always continuous and differentiable. So it is continuous in any interval. It is also differentiable in any open interval a comma b, right? And whether fa equal to fb? Right? So try to understand step by step, right? This is true. The function is continuous and differentiable for all the values of x. Right, for all the values of x, so it is continuous in any interval a comma b, it is differentiable in any interval a comma b. So this is true for all a and b. This is true for all values of a and b, no problem. But fa equal to fb, let me tell you that if fa equal to fb, right now I don't know, because I don't know what values of a and b I'm going to talk about. But if fa equal to fb, then what will happen, everybody? ये तो हम जानते हैं ना. If fa equal to fb, then Rolle's theorem holds. And if the Rolle's theorem holds, guys, what is the conclusion of the Rolle's theorem? Okay, then there will be at least one point in the interval. Which interval? A comma B. What is A and B? That also I will explain you. But there will be at least one point in the interval A comma B, right? Where f dash x equal to 0. Now sir, what is f dash x equal to 0? Now sir, what is f dash x equal to 0? Isko 0 se equate kiya, so you get the given equation of the question. You get the given equation of the question. I hope you are getting it. Then you get the given equation of the question, right? So that is why whenever whatever is the given equation, call that expression as f dash x, then see what is fx, and if the fx satisfies the Rolle's theorem, then in that interval a comma b, f dash x will be 0. We will get one root in the interval. So f dash x equal to 0. Okay, that is, what is f dash x equal to 0? F dash x equal to 0 means 3ax square plus 2bx plus c equal to 0 will have one root. एकदम detail में समझा रहा हूं since it is the first question, going slow. One root in interval a comma b. Now the question is asking the same thing. Now it will have one root in what interval? So we need to find a and b. How to find a and b? fa should be equal to fb, right? Next question, what is there in your mind? I know. Next question, what is there in your mind? That I also know. How to find a and b, sir? Answer भी बता देता हूँ. How you are going to find the a and b? To find f a and b, you should just take the value of a and b such that fa should be equal to fb, right? Now what is the fx function, guys? The fx function, after integrating this, we got ax cube plus bx square plus cx plus d, right? Now एक काम करेंगे. We will go option by option. Sir, what is the option number a? The option number a is minus 1 comma 1. The option number a is minus 1 comma 1. So what is f minus 1? What should be the value for f minus 1? Everybody keep looking into this. So f minus 1 ka cube is minus 1. So minus a, then plus b, then minus c plus d. Then what should be the f1? The f1 is x की जगह 1 रखा, तो you directly get a plus b plus c plus d. A plus b plus c plus d. अच्छा, okay. Are they equal? No, they are not equal. No, they are not equal. Okay, so sir, let's try something else, right? Let us now try the option number b here. What is the option number b? Have a look into this. 0 comma 1. 0 comma 1. So what should be the value of f0, sir? What should be f0? 0 0 0 d, right? What should be the value of f1? A plus b plus c plus d. A plus b plus c plus d. But still, sir, they are not equal. Nahi, guys. See, there is a condition in the question that a plus b plus c is equal to the 0, right? So this part is equal to 0 plus d, and hence it is d, and hence it is equal to what? Hence that is equal to the d, and then these values matches. F of a equals f of b, and the option which satisfies fa equal to fb, then rest I have already explained you, and then that option is the correct option. Option number b. Good evening, no problem, Vanya. Thank you, Anu. All right, guys, that's it. Learning, enjoying, so do not forget to like the session. Yes, let's come here. One of the roots of equation. Which equation? Sin x plus x cos x equal to 0 lie in what interval? One of the roots of the equation. Sin x plus x cos x equal to 0 lie in what interval? Tell me. Okay, if you have really understood, so you should be able to get this. If there is any doubt, try to rectify with the next question, because it is a similar question now I am taking. It is the similar question now that I have taken in front of you. Please try to respond to this question quickly. Yes, guys? Please try to respond to the question and keep liking the session once you get the answer. Right. One of the root of the equation. So what is the first thing I told you? Whatever may be the expression, whatever may be the left hand side, let that be the f dash x. let the f dash x is equal to sine of x plus x cos x. Sine of x plus x cos x. Okay? Sin x plus x cos x. So what should be the value of fx then? Fx is the integral of this. Now, there is one thing you can think. Rather than integrating it, if you try to integrate this by the formula, if you try to integrate by the formula x into cos x, product of two functions, so you may apply integration by parts. Thoda sa lengthy hoga. I'll give you a simple explanation of this. This is like d by dx of x, because d by dx of x is 1. That is why it is not seen here. Multiplied by sin x plus x ko constant rakhte hue, then it is the d by dx of sin x. Cos x is the differentiation of sin x. Now what do you understand? I have made it simple. You can solve integration by part also, but I have made it little simple. So differentiation of x, sin x is constant. When x is constant, differentiation of sin x. So that is basically the product rule of differentiation. Okay, so this is nothing but d by dx of product of which function? One is the x, one is known as the sin x. One is the x, one is known as the sin x. Right, this is what? This is the value of the derivative of the function. This is the f dash x. And sir, if this is the f dash x, what should be the fx? Integration will cancel the differentiation part and you will be left with x sin x. So what is the fx? X sin x. Okay, what is the fx? X sin x. Now x is a polynomial function. What is x? X comes into the polynomial function category. Sin x and cos x, sinusoids. Right. If two functions are continuous and differentiable, then their product, their addition, their subtraction, all of them is also continuous and differentiable, and that is what we have learned. So that means x into sin x, both are always continuous and differentiable. The fx is also always continuous and differentiable. The fx is also always continuous and differentiable. There is no issue in that. The fx is also the always continuous and differentiable. The fx is also the always continuous and differentiable. Okay, chalo. Right, let's move ahead. This is always continuous and differentiable, no doubt. Now, if it is always continuous and differentiable, what you need to check? Right, what you need to check? You just need to check one thing. fa equal to fb. Now, the detailed logic, once again, I am not repeating. The logic of fa equal to fb, the logic of solving the equation using mean value theorem is discussed in the previous question. Just in the previous question few minutes back. Let us just write down the final answer. Okay, just by matching with the option. What is the option number A? Minus pi by 2 comma 0, sir. Minus pi comma 0. Acha. What should be the value of fx? Fx is already computed. X into sin x. Right. So what is the f minus pi by 2? First point, fa. F minus pi by 2 is minus pi by 2 sin minus pi by 2. Sin minus pi by 2 is minus 1. So minus cancel. This will be the plus pi by 2 answer. What should be the f0? F0. 0 into 0. That is just 0. So they do not match. Here, fa does not equal to the fb. So this cannot be the possible answer. I will go to the next option in sequence. Yeah, definitely in this you have to take the help of the option. The option here is 0 comma pi. The option here is the 0 comma pi. The option here is the 0 comma pi. So what should be the value of f0? That is 0. What should be the value of f pi? Now f pi is equal to pi into sin pi, but eventually sin pi is 0. Okay. Eventually the sin pi is 0. That's it. Okay. So now clearly both are 0, and now clearly you get the picture that f of A is equal to the f of B, and hence the option number B, since it's a MCQ question, option number B matched. Go ahead. Please do note that if suppose they gave MSQ type question from this category, so you can have to check other, because this equation can have multiple roots, one of them lying in 0, pi, one of them in other interval also. So because now MSQ questions are there. If suppose it was MSQ, I have to check all the option. Right now it is MCQ, so then only one option matched. I can go forward for the next question. Now moving ahead to the next question, you see a GATE 19 2-mark question coming up. Consider a differentiable function fx on the set of real numbers, such that f minus 1 is 0 and modulus of f dash x less than equal to 2. Modulus of f dash x less than equal to 2. Given these conditions, which of the following inequalities is necessarily true for all x belonging to minus 2, 2? For all the x belonging to minus 2, 2. Right. Now you will see, sir, what is this? Some inequality type of case coming up. Yes. So here, earlier we saw Rolle's theorem. Now Lagrange's mean value theorem will come into picture and talk about inequalities. Consider a differentiable function fx. Clearly told it is differentiable on the set of real numbers such that f of minus 1 is 0, f dash x is always, modulus of f dash x is always less than equal to 2. With these conditions, which of the following inequality is necessarily true for all x in the interval minus 2, 2? Acha. Important point. What is told? F of x, it is a differentiable function. It is differentiable. So automatically, it is a differentiable function. So automatically it is continuous also. If it is a differentiable function, na sir, so automatically it is continuous also. उसमें तो कोई doubt नहीं होना चाहिए हमें. So it is automatically continuous. No problem. It is automatically continuous. Now please see, we have a function fx. Now we have a function fx, which is, let me say that, let us now, because it's a continuous and differentiable function, okay, let's apply LMVT, Lagrange's mean value theorem, for the function fx in interval. Now we want for all the values of x between minus 2, 2. Let's take the interval. Let us take the interval minus 1, x, where x can be anywhere between minus 2 to 2. Now you will ask her, why only minus 1? Why only minus 1? Because the value of the function at minus 1 is given. Because function to given nahi hai. A particular value is given, that is at x equal to minus 1. So that's why I'm trying to use this point. Okay, that's why I'm trying to use this point. So let's apply LMVT for the function is minus 1, x. Why I can apply the LMVT? Because the function is continuous in minus 1, x. Actually, the statement says it is a differentiable function on the set of real numbers. Matlab it is differentiable everywhere, so it is continuous everywhere. Without continuity, differentiability is not possible. We have learned this in the class number 1 only, right? So it is differentiable in the open interval minus 1, x also, right? Then what? Then let's write down here. Then let's place the result here. Then there is a point, okay. Then in the interval minus 1, x, there will be at least one point where f dash x is given by fb minus fa. fb minus fa. What is the fb? F of x minus fa minus 1 divided by b minus a. LMVT na? fb minus fa divided by b minus a. If it is Rolle's condition, then f dash x is 0. Or else it is f dash x equal to fb minus fa divided by the b minus a. Let us just complete the calculation part. Let us just now complete the calculation part, right? So I have the f dash x is equal to f of x minus f minus 1. That's why I told you I am using f minus 1, so that one of the value can be substituted. It becomes easy. Divided by x minus 1, that becomes the x plus 1. Inequality is required for fx na? Inequality is required for fx, right? So what should be the fx? Dekh lete hain. What should be the fx? Fx, send the x plus 1 on the other side. It is the x plus 1 is multiplied by the f dash x. X plus 1 is multiplied by the f dash x. The fx is equal to the x plus 1 is multiplied by f dash x. Acha. So what should be? We know that We know that. What is given? Given modulus of f dash x less than equal to 2. चलो यहाँ पे आ जाते हैं. Given modulus of f dash x less than equal to 2. So that means multiply x plus 1 on both the sides. Modulus of x plus 1 f dash x is less than equal to twice modulus of x plus 1. I have multiplied by mod of x plus 1 on both the sides, right? I have multiplied by x plus 1 on both the sides. No issue in that, right? Yes, Nishu, we are applying the LMBT only, right? Now, what is x plus 1? F dash x, it is fx. So we have modulus of fx less than equal to twice modulus of x plus 1. We have modulus of fx is less than equal to 2 mod of x plus 1, right? That is option number C. Actually, here mod should come properly, but since no problem, yeah, we are able to match it up. The correct answer is the option number C, no doubt. The option number C is the correct answer, okay? So, modulus of fx is less than equal to twice modulus of x plus 1 is the very correct answer for this particular question. Hope it is clear. If it isn't, you are always open and free to ask and discuss the doubt. You should be always free and open to discuss up the doubt, okay? Let's move ahead to the next question. If you have understood this, chalo, how to test you have understood this? Let's try a question little bit related to it. Then you will get an idea. And if you are able to solve this question, do not forget to like if you haven't liked this. Okay. Suppose that f R to R, okay, domain to range. The domain of the function is also all real numbers. The range of the function is also all real numbers. Is a continuous function on the interval minus 3, 3 and a differentiable function in the interval minus 3, 3 such that for every x in the interval f dash x is less than equal to 2, right? If f minus 3 is 7, then f3 is at most. Then f3 is at most what? Okay, f3 is at most what? Say the doubt future, and let's also follow this question. Then if you have any more doubt, please, let's discuss that. See, one logic is last question was asking inequality on fx. Now, what is this question asking? Future, let's try to understand this. Fx is at most, right? F3 is at most. They are asking what should be the at most matlab maximum. What should be the maximum value of the f3? ठीक है ना? What should be the maximum value of f3? That is what they are asking. Okay, that means if I get the maximum value of f3, I can say that f3 is less than equal to something. Suppose f3 maximum value is 100, for example. Maximum 100, matlab it will be less than or equal to 100. That means again the question is indirectly asking about the inequality ki fx, for any value of x, यहाँ पे 3 बोला है, fx less than equal to something like the last question. And even if you focus very clearly on the last question, the inequality on the derivative was given. Inequality of derivative was given. Chalo, let's go and see. F dash x less than equal to 2. That's what is given in the last question. Similarly, something is given here. F dash x is less than equal to 2. Right, and this is a little recent question, GATE 21 1 mark. So, given the inequality of f dash x, we can find the inequality of fx and even vice versa. Right, because we can relate the f dash x and fx by the Lagrange's mean value theorem. Right. Now, clearly the question says, guys, one thing. Clearly the question says it is continuous, right, and it is differentiable for all values between minus 3 to 3. Now, let's apply what? Let's apply the LMVT for the function fx in what interval? Let us apply the LMVT for the function fx in what interval? In what interval? Right, in the interval minus 3, 3. Sir, why? Okay, first of all, the continuity and differentiability is given in that interval. And one more thing, guys, we want the condition of f3 and we are given one value f minus 3. So it is a wise decision to use one of the point as minus 3, another one is f3. Okay, so let's apply the LMVT for fx in minus 3, 3. Yeah, I can clearly say that in this interval, I can clearly say that the function is continuous in the closed interval minus 3 comma 3. I say means question is actually given you this data. It is also differentiable in the open interval minus 3 comma 3. Then what happens? Then LMVT result will come. Yeah, some answers are there in the comment box, which is correct. Yes, 19 is going to be the answer. Okay, so then what happens? यहाँ से start करते हैं. Right. Then in the interval minus 3 comma 3, there will be one point which will satisfy f dash x equal to fb minus fa. This is a, this is b. fb minus fa divided by b minus a. Lagrange's result, LMVT result. So f dash x is equal to fb, that is the f3, minus fa, that is f minus 3, divided by 3 minus 3. So what should be the value for the f3? That is unknown. What should be the value for f minus 3? F minus 3 given has 7 is divided by 3 minus 3, that is equal to the 6. Right. So now what should be the value for f3? What should be the value for f3? f3 will be given by 6 times f dash plus 7. 6 f dash x plus 7. It is given by the formula 6 f dash x plus the 7. 6 f dash x plus 7. Now we are given the condition on f dash x. F dash x less than equal to 2. F dash x दिया है ना, f dash x less than equal to 2. Right. If the f dash x less than equal to 2 is the given part, then what I can say, multiply by 6. So 6 f dash x will be less than equal to 12. Right. Multiplied by 6. Then add 7. 6 f dash x plus 7 will be less than equal to 12 plus 7, that is 19. And what is 6 f dash x plus 7? That is equal to the f3. Right. f3 is less than equal to what value? 19. Right. Or I can say that f3 max value less than equal to 19 hai, so maximum it can be 19. Answer is closed. Right, the answer is 1919. And if you are getting the answer, solving the equation, solving inequality, do not forget to like this question. Yeah, see, these are little expected question, exactly this question or modified question. See guys, let me tell you one very clear thing. You know, whenever I talk about strategy of mathematics, if you have followed the earlier classes, I very, very clearly tell you that you should try to solve the previous year question of all branches. Reason I will explain. I'll tell you. ये देखो, GATE 19, 2 mark question, electronics का था. This was easy question in GATE 2019. Now, GATE 21, computer science question. We know that question same nahi hai. It is, but if somebody able to solve, if somebody is clear with the concept of that GATE 19 question, 110% he can solve the GATE 21 question also. Right? Question is different, but the idea is copied. Na? That's what I keep telling you. But that was easy question. This is CSE. That is why maths, it is highly suggestible to solve the PYQ of EC, EE, mechanical, civil and computer science. सबका solve करना आपको आना चाहिए. That is very mandatory. That is the very much mandatory. Right? That is the very much mandatory. Okay. Then let's move ahead. Then definitely let's move ahead. No issues in that. Okay, chalo. No issues in that. Let's move ahead and discuss. Okay, so yeah, please try to take up the PYQs of all the branches. One more thing I have to update you here, that yeah, there are other questions also, but before we go to that other question, yes, Nishu. Bhaskar, I'll give you an update on that. There seems to be some trouble. We are working hard on it. By the time, today what we are learning? MVT. एप्लीकेशन सब कुछ स्मॉल रखते हैं. let's make a simple password today randomly. AMVT, application mean value theorem. It's AMVT. Okay. Yes guys, so where will I share the Telegram? Yeah, there seems to be some issue in the Telegram. Okay, exactly, we are trying to work out, some wrong allegations are there, but we are trying to work out on that. But by that time guys, by that time because the last two PDFs I think are also remaining. Okay, so I'll share you the last two PDF, last PDF, whatever is remaining, today's PDF. By that time I'll share you, right, by that time I'll share you just one thing. I'll give you an instant solution. Yes guys, by that time please join this particular Telegram channel so that at least it is not your loss. You'll get the PDF. This is also one more alternate Telegram channel. We'll try to be more active in this for maybe 1 or 2 days. By the time we try to take that one, retrieve that one, right? So this is one more link I have shared to you. You can join this. Okay, and once that is active, definitely I'll give you a update on that and we'll keep discussing our progress there. Okay, cool. So do not hesitate in joining this so that the today's PDF with the password AMVT and the previous class PDF mean value theorem also I will share it together. Both I will share it up. Okay, both I will share it, don't worry, right? Chalo, all cool, all cool, all cool, all cool. Let's move ahead. Okay, let us then move ahead. One more application based question. Let us discuss this. Okay, let us discuss this one more application based question related to little bit similar application. Yeah, let's have a look into this now. The related question it is, since f dash x is equal to 1 upon 1 plus x square for all values of x and f0 is equal to 0, then an interval in which f2 lies. Again, inequality, f2 lies in what interval? f2 lies in the what interval? F dash x is equal to 1 upon 1 plus x square for all x and f0 is equal to the 0, then an interval in which f2 lies. Then an interval in which f2 lies. Kindly tell me. Then an interval in which f2 lies. Thank you, Arsalam. God bless you and good that you're liking it. Chalo, so let's keep on doing this. f2 lies in what interval? Once again, some range, some inequality regarding to the f2. Now, f dash x is equal to 1 upon 1 plus x square. Now, there is a simple method for this. Sometimes, sometimes we need to be very straightforward also. Sometimes we need to be straightforward also. So f dash x is equal to 1 upon 1 plus x square. So sir, what is the value of fx? What is the value of fx? Tan inverse x. Indefinite integral hai, to add the constant of integral, because 1 upon 1 plus x square is the differentiation of tan inverse x. Na? So fx is tan inverse x plus c. But what is given to you? f0 equal to 0. So 0 is equal to tan inverse 0 plus c. Tan inverse 0 is also 0. So the value of c is equal to the 0. Correct hai? So what should be the value of c? So that is also equal to 0. So what is the fx? Simply the fx is tan inverse x. Now see what is the question asking. Okay, what is the question asking? f2 का हम exact value बता देंगे. What is the question asking? f2. f2 is given by the tan inverse 2. Sir, what is the value of tan inverse 2? Just open up your virtual calculator and get the answer. Let me get the answer here. What should be the value of f2? That's what I want na. ये लीजिए. Yes, that is 63. Yeah, actually it should be in the form of a radian. Let's put it in the form of a radian actually, first of all. Yeah. 1.107. The exact value is there in front of me. 1.107. So the correct answer is, in what interval this one is lying? 1.107. Right, it is from 0.4 say 2. It is clearly from the 0.4 say 2. Now this is direct, but previous to this two questions, the two questions previous to this, that couldn't be solved because in those two questions function was not given. Here the function is given. But now suppose the function is again unknown. Yeah, suppose there is a function whose integration formula is unknown, because there are some functions which cannot be integrated. So what to do in that question? Okay, so in that general situation, that will be once again the LMVT based question. Right? How you can solve the LMVT based question here? F0 is 0 and the f dash x is equal to 1 upon 1 plus x square for all values of x. क्या करेंगे? Apply the LMVT in 0, 2. Sir, why 0, 2? Because I want the information about f2. I want the information at 2 and I'm given the information of 0. Right? That's why I'm making the interval as 0, 2. Right? 0, 2. Acha, f dash x is given. That means function is differentiable, na? F dash x is equal to 1 upon 1 plus x square for all x. इसका मतलब क्या है? What do you understand from this? That languages should be clear now. What do you understand from this language? That means it is differentiable for all x. And if it is differentiable, so also continuous. Without continuity, differentiability cannot be guaranteed. So also continuous for all x. And because it is continuous differentiable for all x, so you can apply the LMVT in any type of interval, 0, 2 or 0, anything or anything. Acha ji. Okay. Then what happens? There is one point in the interval 0, 2 where f dash x is given by fb minus fa divided by b minus a. What is the fb? That is the f2. Then minus f0 divided by 2 minus 0. What should be the value for f2? What should be the value for f0? Right, f0 given, eh? f0 is 0 divided by 2 minus 0. So what is the answer for f2? Okay, this is part 0 divided by 2. 2 ko yahan shift kiya, it is equal to the 2f dash x. What is the f2? It is equal to the 2f dash x. What should be the value of f2? It is equal to the 2f dash x. Right? Now it lies in what interval? It is equal to 2f dash x, that is 2 upon 1 plus x square. We have applied LMVT in the interval 0, 2. Right? In the interval 0, 2. Okay. So agar x ko 0 rakha, we have applied the interval 0, 2. Na? The interval is 0, 2. Right? So f2 for one of the point will be 2 upon 1 plus 0 and f2 for the other point, that will be 2 upon 1 plus 2 square. That is 2 by 5, 0.4. This is 2 by 1, that is equal to 2. Right? This is the max value. This is the min value. Right? So combining this, we can say that in the interval 0, 2, 0.4 less than equal to f2 less than equal to 2. So f2 lies in what interval? 0.4 say 2. Option number B. That's how I get it. Right. Okay. Okay, so that is how I'm getting the exact interval, but I told you for some questions you can be even solving direct. The method number 1 that is specified here is the direct method. That is known as the direct method. But when can I apply the direct method? When the function is given and that is integrable. The f dash x is given and I can integrate as an fx. In the previous two questions, there is no function given. So we have to use LMVT indirectly only. Right? This can be solved directly or also by LMVT. By LMVT, we get the exact interval. By direct, I get the value 1.107. It lies in what interval? That is in front of you. 1.1 lies only in the option number B. That's what it is done. Okay, guys. Okay. So this part is done, and yeah, that's it for the session. I hope you have enjoyed it. If you have enjoyed, do like. If you have not enjoyed, you can also dislike. Okay. Okay, yeah, great. Yeah, it's great to be addicted to studies, whatever class it may be one. Yeah, but yeah, if you get addicted, that passion will keep forward and you will never miss out on your targets. You will never miss out on your preparation and your motivation will be there till the end of the preparation. That's what you should have. Now, we'll meet tomorrow once again. Tomorrow means for ECEE. Tomorrow is Thursday, Okay, tomorrow is Thursday. I have that schedule now. Let's talk about that only. Yes. So, as you know, for ECEE and instrumentation student, Tuesday, Thursday, Saturday, Sunday, signal and system. Tomorrow, signal and system, continuous time convolution we will discuss. Okay, so 2 classes we will have on continuous time convolution. One is the methods of solving, one is purely question practice. And maths as it is, MWF Sunday. So next class, Friday, where we are going to learn very, very important, I need to tell you. Very, very important. Now I need to tell you the topic at least. Friday 6 p.m. we have one of the most important topic of calculus and also very important topic of the overall engineering maths. That is the maxima and minima complete concept. And let me tell you guys, nearly we'll have the 3 classes for the maxima and minima because it's a very crucial topic. In the first class, we'll understand its concept A to Z in detail. Next 2 classes, variety of questions we will solve. Do not forget to join these. Do not absolutely forget to join this. Maxima, minima at 6 p.m. All right and all cool. That's it for my session. With this, I'll take your leave for today. Yeah, let me just keep you updated that, the BYJU'S Exam Prep students really outshined in the GATE 22 examination. This is the Hall of Fame. We have All India Rank 1, All India Rank 2, All India Rank 3, and there are multiple ranks under 50 and many, many ranks under 100 also. I wish, I hope, I pray that, you are also one of them in the upcoming results. That is a GATE 23 or GATE 24 exam. With this, Rakesh Sir signing off. Keep following, and as I told you, technical, non-technical sessions and some informative sessions, how to apply for foreign universities through GATE, whether they know artificial intelligence is because it's a hot branch, so how it can attract you, why it is a very important branch these days for MTech specialization, how some strategy based sessions also we'll discuss. So many things coming up on this channel. Do not forget to subscribe, to attend, and continue watching these sessions. Bye bye. Thank you. Stay safe and do take care of yourself.